when you drive by like a construction site, right, it's clear that, there's a lot of coordination that needs to happen between all the different disciplines. So there's the structural, plumbing, mechanical, electrical, civil engineering, if you're going to do storm drains and piping and sanitary and natural gas, there's just so many different people all working at the construction site at the same time. So an incredible amount of coordination needs to take place. It's just as important in the digital space to collaborate as it is on the construction site itself.
Welcome to another episode of the Next Generation Design Podcast. I'm your host, Jennifer Piper. In this episode, I'm welcoming back Derek England, NX Product Manager for AEC and BIM at Siemens Digital Industries Software. In part 2 of our 3-part series with Derek, we're talking all about the benefits of collaboration using multidiscipline building information modeling tools in the architecture, engineering, and construction industry. Before we begin today, Derek, could you reintroduce yourself to the audience and tell us a little bit about yourself?
I'm Derek England. I'm an NX Product Manager for AEC and BIM at Siemens Digital Industries Software. I've been with the company for over 25 years now, and I've been able to be fortunate to work with some of the most innovative companies around and understanding their workflows and helping them to achieve their productivity goals. Yeah, my job is to make sure that NX is the best there is for this industry and continually, search and work with customers to figure out how to enhance the software so that it's the most efficient for them.
It's great to have you back, Derek. Today, we're talking all about collaboration and coordination of BIM tools in the AEC sphere. What are some of the real-world challenges regarding this issue that you see general contractors experiencing today?
The general contractor, he is responsible for coordinating all the engineering construction activities, right, with the subcontractors. So they'll have one contractor that's responsible for, designing and installing the HVAC system. You'll have one contractor responsible for piping, another for electrical, et cetera, et cetera. And so the challenges is changes in one area will impact many different disciplines, right? And so his responsibility as a general contractor needs to be able to, when he finds these issues, to go back and communicate back to them and say, okay, these things need to change. And one of the challenges is that everybody kind of has their own source of the truth, right? They've got their own version of the part, but they're not everyone's reading from the same script, I guess. And so,
yep, exactly.
Yeah, so it's difficult for them to make those kind of changes.
And I would imagine that's further complicated with the number of different technologies being used. Is that correct?
Typically, each one of these disciplines are using different software as well. So if I'm a contractor and my job is to design HVAC, I'm going to use whatever software is the best for HVAC, right? And the guy over here who's designing plumbing, he's going to use the software best for designing plumbing systems, right? Piping systems, and so on and so forth, right? And so now the general contractor has to take data from lots of different systems as well and kind of integrate it all together. And this process of integrating the data and collecting it, and it's error prone, right? And when changes are made, it's really difficult to understand what the impact is, to all these different areas for lots of different reasons, right? So if I decide I want to make an opening here on this wall and I need to add a beam that's going to impact, piping and electrical and HVAC, you need to communicate that all to them. And because each of them work in their own silos, it's really difficult to find these things and communicate them in a timely manner.
So can you walk us through what the process looks like currently? How does a general contractor typically ensure that everyone is working in harmony?
It doesn't feel very harmonious a lot of times. You think about if you've ever been to an orchestra or something like that, it's kind of like when you first sit down and the lights kind of go a little bit dim and you hear them kind of start playing. They don't immediately start playing this beautiful music. It kind of sounds a little bit chaotic. You hear them warming up, and it sounds a little bit chaotic how they do that, but in reality they're just kind of all getting in sync, right?
Sure.
And that's kind of what a design review, it's like getting everyone in sync. So in an orchestra, they'll the oboe will play a note, like an A note, and then the violin checks to make sure he's got the same A note. And then the other woodwinds and brass and strings, they all make sure they have the same note. And then now they're all in sync. Now they're ready to make music. Now they can be harmonious, right? And that's kind of what the design review is like. It's like, okay, we need to make sure everybody's in sync. Do we all have the same design? Are we all reading from the same script? And kind of they figure that out at a design review. But it feels like they don't start playing music. They just say, okay, great, we're all in tune. Let's go back and start practicing on our own, right? And it just feels like they constantly are getting in tune, but never really making music together. And I think that's where we have opportunities to maybe, we'd like to make music together, not just warm up and get our instruments in tune from time to time.
What would you say makes it so hard to collaborate and coordinate those design reviews?
The way it typically works today is everybody works independently. And how often they do design reviews can be, once a week. It could be once every other week. It could be, but in reality, they're working a long period of time independently from each other, right? And so they're making decisions, not in context with the other disciplines, right? So I may make a design change that makes perfectly good sense to me, but in context of the overall design, it's not so great. And if it impacts somebody else, that's somebody else's problem, right?
Yeah.
And so this process too of collecting all this data can take several days. That you ask for the data, and it takes me a while to save my data and collect all the data, from all my different designers, right? They've got to collect it and integrate it on their side as a contractor, and then they kind of give it to the general contractor who's got to integrate all the disciplines together, and then they can find the clashes and interferences and things like that. The challenging part is by the time he finds these clashes and interferences, that data is pretty old. It could be a week old or 2 weeks old.
So in the meantime, everyone has continued working because really they have no reason not to.
Now all of a sudden it's like, I've been working 2 weeks already since I gave my last version.
Right.
What's changed? I don't know. And so it takes a lot of time for them to figure out, okay, this is what my data used to look like, or this is what it looks like now. Does that change still impact me? And so they spend a lot of time just trying to figure out what's changed.
It sounds like a lot of people are doing 2 or 3 times more work than they really need to. How have you seen this play out in the real world?
I worked with this one company, and they were convinced that they were going to use a best in breed solution, right? And there's a lot of benefits to like best in breed, right? It's you basically use the best software for the best thing, the best task, right? And it's good, right? It's easy to implement. I can be really flexible in the type of tools I use, and so they said this is the best solution, right? And so, but what they found was they were never able to get enough design cycles in. The integration of all these different tools made it really difficult, right? So they really would like to have gotten to the point where they could do, dozens of design iterations and dozens of options, before design freeze. But ultimately what ended up is they would get 1 or maybe 2 viable options, and then they're choosing between those. And it wasn't optimal. They knew it wasn't optimal, but because it took so long to get there, that's kind of where they were.
Is there anyone who's been able to figure out the collaboration issue? Do you have any examples of a company that's doing this process particularly well?
A company called SSF Engineering, and it's a industry respected German civil engineering and construction company, and they design large complex infrastructure construction projects. One of the ones they design it's really cool. So I go to Germany quite often, and I always take the trains. They're great, and but whenever I go between like Stuttgart or Frankfurt and to Munich, it always seems like these high-speed trains aren't any faster than driving, and the reason why is because there's this one stretch that's really slow, and it's because it has like lots of turns and a steep climb, and high-speed trains really just don't go that fast on those areas. And so they've redone it, and they've designed this new track that's for high-speed trains that'll cut that time in half. Also used NX to do things like 4D construction sequencing, right? So they could actually visualize, this is what the construction site looks like on, day one. This is what it looks like on, after 1 month, after 2 months.
And they're actually able to use that data collaboratively?
They were able to use that same data over and over again through lots of different disciplines. They also, because they were all using a common tool, it became really easy to do these design reviews. They said it literally, they save their work on a conference call, and they can immediately start an online meeting within minutes, right? And that was something they could never do before. Because the data was always in the same system. It really boosted their efficiency and eliminated errors, compared to when they were using, multiple systems that weren't integrated together. So these design reviews are much easier when you're working in a common design environment. Each designer is working with live data. So when design changes occur, they immediately see that. Everybody immediately sees it, and they can react immediately instead of waiting weeks to integrate and review and get feedback. It's immediately. And so that enables them to deliver on time.
Flexibility of the solution seems to play a big role in a lot of the best practices. Can you expand on how that flexibility is helpful?
Flexibility is a key point. They talked about, there's lots of software out there that'll assist in designing a bridge or a roadway, but these designs are, need to adapt to different terrain and different circumstances. And so lots of times this out of the box, here's my template bridge doesn't, roadway doesn't fit into that scenario. And it's very difficult to kind of force the software to do something it wasn't meant to do, right? And that was one of the things they really loved about NX was this flexibility to just, I wanted to design the roadway to do this. In this one section, I need to change it. I'm not constrained by some, predefined rule in the software.
Does the digital twin come into play at all?
All along, they could always represent and see what's happening. So when the guys wanted to see, if I made a design change, I could immediately see how that impacted all the other disciplines. And when I made a change and found a mistake, it immediately got applied and represented the digital twin. So many issues are found on site. On-site decisions are made to modify the design. Those on-site modifications never make it back into the digital twin, right? And so it's important, and really beneficial to be able to find all those issues early on to ensure that it really gets an accurate representation for the digital twin.
And can you tell us a little bit more about the idea of a common design environment?
Most AEC design software stores data in a single part file, right? It's a single file, right? And so for architects, managing all this data in a single file, is for the most part fine, right? The challenges come when you need to collaborate with others, right? When you need to get a whole team of people, many people, how do you, collaborate with a single part file? So one way to do it is you probably familiar with something like, Google Docs, right? The ability to kind of work together, but it's not really satisfactory when, you've got really complex design processes. Or your needs are much different, right? I might be designing one thing. I don't want to see everything associated with, the formwork and the scaffolding because that's not what I'm interested in.
So it goes back to the need to collaborate amongst different disciplines. Do you see the single file issue as the biggest hurdle to collaboration?
It becomes difficult when you have different objectives for the need of the data. A single part might work great for an architect. It really is difficult during engineering construction. This scalability issue was one of the key complaints in that open letter to Autodesk a couple years ago. When the design is stored in a single file, it's challenging to leverage things just like multiple core. How do you, have multiple processors working, when it's all stored in a single part file? And so you see more and more customers complaining that the performance is getting worse and worse because they have no way to really distribute that design and leverage multiple CPUs. When that happens, right, nobody wants to get bogged down, and so they create their own version of the design, right? And and that's everybody has their own version. It's an unfortunate circumstance, but kind of what they do.
It sounds like it would be a pretty major roadblock for productivity.
They spend a lot of time trying to determine, what's changed. So the guy who's in charge of the design, he'll make a change, and then everybody has to figure out what's changed. They don't really know. They have to spend a lot of time looking for it. It's just unique to this industry as well. You don't see it like in automotive. You don't see it in aerospace or machinery. These tools, enable distributed design using like assemblies and components.
Can you elaborate a little bit on that? How much of an obstacle does the single part file really create?
With a single part file, like you'll design like an element. Like I'm going to design a restroom, let's say, and I've designed a men's and women's restroom that's represented on every floor of the building. Today I would just copy and paste it and put it in all the different levels, right? But really now these are all unique instances, right? So if I decide later that I said, oh, I need to change something in one of them, all of them now are wrong, right? You don't just change it once and propagate that change everywhere. They're all wrong, right? And so, yeah, it's not ideal. It's better if you had, take that instance and replicate it multiple times, make it one change, and see that lots of times. So if I'm the guy who needs to do like the concrete work, right? I need to put in like form work, right? So my design needs to have form work. The guy who's doing, steel work, he might not care at all about the form work. Where does my form work live, right? We don't have a single source of truth that has everything in it. It'd be great if you had like a single source of truth that had everything in it, and then only the things I want to see are the things I get to see, right? And other people don't have to load it if they don't want to.
I can imagine that poor collaboration would have a pretty severe impact on those builds as well.
You're always going to find mistakes on site somehow. Sometimes it's human error, sometimes it's just got missed. But it's the problems are really compounded when you're working with stale data or out-of-date data, and you're constantly translating data between different CAD tools, and you're trying to integrate it together. There's great tools out there that have made progress in making the translations better and the integrations, better. But in reality, you're not getting enough design cycles like that I kind of talked about. And so in the end, you're not finding all the mistakes in time because you're on a deadline and you're pushed to start, building. And, so what happens are mistakes are made, right? And then every single time mistakes are made, you cause delays, right? And you cause wasted materials. You've ordered the wrong, product, or the equipment didn't get delivered in time. And so, this eats into their profit margins. In this industry, the profit margins are thin, and you just don't have the flexibility to make these kind of errors. So you're either forced to kind of take a hit or turn around and, charge the owner a lot more money and say, hey, there's this mistake, you need to pay more. And so that's not a good solution either.
So Derek, looking ahead, what would you say the BIM collaboration space looks like in the next 5 years?
Well, you can start to see that, the cloud is really a big deal, right? The cloud enables you to get data put somewhere that everyone can access it, right? So today, lots of times it lives like on somebody's computer, on the disk drive, right? That only a few people have access to. So by putting on the cloud, at least everybody can access the same data. So that certainly will be kind of the future is leveraging the cloud to make this data accessible from any device. How
do you see that accessibility changing the industry?
These design silos can't exist. We can't have these people working, in isolation, designing, their specific thing out of context of the rest of the design. You really need to have an environment where everybody can see and work together. That has to happen to ensure that we don't get these delays and missed interferences and clashes and things like that. As soon as changes occur, right, it would be, if I'm designing something and something all of a sudden, comes into my space, I imagine like I'm going to get notified of it. It's not going to take somebody else to tell me this. I'm just going to be working and it's going to say, hey, you had, somebody just put an HVAC unit, HVAC duct right through your space. Is that okay? And so I imagine like there's going to be a more dynamic, interactive way that these disciplines work together and some notifications. And so when that happens, these interferences just are found immediately. I'll start adapting to that right away. I'm not going to wait until, a week from now when we do our designer review till I discover that. I'll start working on it, immediately. And so I imagine, these designer reviews will be much, much different. You're not going to be finding interference and clashes. Those will be resolved ahead of time. These designer reviews will really be, communicating large changes or, exploring design opportunities or something like that. But they won't be like finding, interferences anymore. There'll be much more high level discussions.
Are there any other big changes that you see on the horizon? What about in terms of the digital twin?
Another area too is that really the way we document on-site issues and the way we capture these on-site issues, we can't have digital twins, if decisions are being made on site, changes are being made on site, and these aren't documented in the digital twin. And so somehow we need to pull this into our digital twin and make sure all these changes are documented and replicated in our digital twin. And so I think you're going to see that, in the future, no construction project will be done without a digital twin, without the ability to, digitally represent what's physically there. You see more and more, governments requiring, 3D data, but I think more and more it'll be like, we really want a full digital twin. And you actually see people retroactively doing that. Like I know the German government is paying to take projects that were done in 2D, maybe 5 years ago, and we really want a 3D representation of this. We really want a digital twin, and they'll pay people to retroactively create these digital twins. So you can bet that in the future, all projects will be, make sure that they're leveraging these principles and have an accurate digital twin.
Wow. So we're looking at a future where things like infrastructure maintenance could be completely revolutionized. Thank you so much to Derek for joining us today. And please stay tuned to Next Generation Design for the final installment of our conversation with Derek in this 3-part series. Thanks also to our listeners for joining today's episode. Join us next time for more discussions about the latest in design innovations and software applications. I'm your host, Jennifer Piper, and this has been Next Generation Design.